Okay, now in this section we'll introduce some device called router here. Now router is a device what we have learned from the basics. It's a device which provides a LAN to LAN communication. If I have a branch office here in Hyderabad and I got one more branch office in a Bangalore or in a different location, if you want these two different branch offices to talk to each other, communicate with each other, we need a router. We need to connect a router to the LAN, to the switch, and we need to have some WAN connection, so we need a router. So if you have two different locations, we need to have two routers, and if you have 4 locations, 4 routers, and if you have 10 locations, we need to have 10 routers. So it's an internetworking device. Internetworking means, it's a group of networks which is used to connect 2 or more different networks. If you want to connect 2 or more different networks, if you want to communicate between 2 or more different networks, we must need a router. Okay, so even let's take an example like here. 2 network means it can be 2 different locations or geographical locations, we can say. Even if you have 2 computers, let's say 192.168.1.1 and I got 192.168.2.1. so maybe when it comes to if you just try to see, they might be a part of the same LAN, maybe they are connected to the same centralized switch, but they will not communicate with each other directly because they might be in the same physical LAN, but physically they might be in the same network, but they are logically different networks. Now even if you want to have communication between these 2 devices, we must need a router. And routing process is required. So when you say different networks, it can be in the same location or it can be in different geographical locations. Okay, so we must need a router and we must do some routing process, and once you do that, then only you will see these 2 different networks will talk to each other. Now similar way, it can be different locations also, like 192.168.1 network and 192.168.2 network, 2 different locations geographically, and if you want to communicate, we need a router again. So the next thing we need to understand which router we need to go for. So we have plenty of vendors in the market who are going to develop plenty of routers here, like Cisco. I got some list of vendors develop the routers: Cisco, Nortel, Cyclers, Juniper. So Cisco is a leader in the market. Cisco is a leading manufacturer of the routers in the market. Okay, so here whatever the routers we are going to learn here in your CCNA course, we are going to learn all about Cisco routers. So when it comes to functionality wise, there won't be much difference when it comes to implementation or the functionality wise or the features wise. All the routers behaves in the same way, all the routers works in the same way, but the way you configure the routers, it will be completely different. The command line, we can say, it will be completely different in a Cisco router when you compare with any other vendor routers. So but here we are going to learn all about Cisco routers here. Okay, so we'll get into command line in our next sections more in detail, but in this section we are getting into some basics of routers, like the hierarchy. So next thing we'll get into some of the hierarchy. Cisco develops the routers in 3-tier hierarchy. Now we got some access level routers, which are typically your low end series routers, low in terms of cost and then low in terms of processing capabilities, and also when you compare with low in number of ports, that will be a little bit less number of ports you will find in your small routers, which we call as access level routers. When you compare with the distribution level routers, are the next level of routers, which are a little bit more expensive than when you compare with the access level, and they have some high-end processing capabilities, and also they have some more number of ports when compared with the access level routers. And then we have some core routers. Core routers are very high speed routers, so very expensive. At the same time, they have some high processing capabilities, and also they support some more number of ports when compared with your small routers. Now more similar to your manufacturers, like let's take an example. If you have some manufacturer, like let's take an example, some Intel is one of the leading manufacturer of your processors inside your computers. Now when it comes to the processors, they develop different range of processors, like we can say that Intel developed some Celeron P4 processors, which are a little bit low-end series processors, and also the latest series from i3, i5, i7 processors, and also this Intel into some developing some very high-speed processors called Xeon and Itanium processors. Let's take an example. In my company, I want to purchase some computers in my company, and there are some users. In that, there are some 20 users who need some basic MS Office applications, and they might be using some basic internet applications. So probably for all these users, I prefer to go with some low-end series processors, which is going to cost me less expensive, and also this will be very good, enough or sufficient for this kind of users. Let's take an example. If you have some other users, where I have some users who are using some multimedia applications, or I can say that they might be using some programming applications like Java, .NET. Probably I prefer to go with some i3, i5, i7 processors, which are more suitable, and that will be a more suitable platform or the processing capabilities. Now, similar way, when you're using some machines for server-based applications like running some Microsoft servers, or I can say a Linux end servers, which is going to control the clients, there are some special processors designed for this kind of applications like Xeon or Itanium processors. So depending upon the requirement, the user requirement may vary. Based on that, we have a different range of processors. Now, similar kind of thing we have on the Cisco routers as well. So we have some low-end sys routers, which are typically used at the small branches, and whereas you have some high-end platforms which are typically used called as core routers, which are generally used in your service provider network or in major head office. Now, how to decide which router to use, that is a major concern here. So let's try to understand on that. So let's try to understand which routers is going to suit in which locations. Let's take an example. I got a main head office which is connecting to maybe in some location. Let's say in my Delhi there is a location here, and it's connecting to some of the branch offices here, and maybe I got one branch office in Hyderabad, maybe in Bangalore, some Chennai. These are different cities here, and then I got some small branch offices near to Hyderabad city. So I got some small branch offices here, and they all are connecting to the main branch office here. Okay. Now, similarly, I got some small branch offices nearby to Bangalore city, so I'm connecting all of them like this. So when it comes to the typical WAN connection, when you talk about any WAN connection, mostly all your small branch offices, they all connect to the main branch office, and then all the main branch offices, they again connect to the head office, more similar way. Okay, because when you are connecting these branch offices, the main concern is a WAN connection is something you have to pay to the service provider. So we need to take a WAN connection, and getting a WAN connection where connecting each and every site is not possible. So because the more number of WAN connections you need, the more expensive it will become. So which is something not a recommended way. So this is a typical design structure which we use. So this is a typical design structure which we use for most of the WAN connections, where we connect all your small branch office. Again, in turn, each and every branch office is having its own LAN with some computers, connects to the main branch office, and all the main branch offices again connect to the head office. So any traffic from this branch office to another branch office has to go via head office, and on the head office router we can provide some centralized security or centralized control, where we can control what traffic is allowed from one branch to another branch. So it's a standard design which we follow. Now which router to use in which location, that makes a big difference here. So if you just try to understand this network, now you can see one router here, which router is connecting to one of the small branch office here. Now if you try to observe here, now this branch office, maybe there is some user is trying to access the resources from this LAN, or maybe the user sitting here is trying to access the resources from any other branch office. So which means now this particular branch or this particular small branch offices which are here, they do carry traffic, but you have a very less amount of traffic flowing on the LAN when you compare with the other branch offices here. Now when you compare here this branch office, you got a huge amount of traffic or more amount of traffic flow when you compare with the small branch offices here, because if any of these users want to talk to each other, they should go via the main branch office. So which means if anyone want to talk to each other, they should go from head office, and if any user from here want to access these resources, it has to come from this branch office here. So which means this particular locations here, they do carry more amount of traffic when you compare with the small branch offices here. And when you come back again, this head office is going to carry a huge amount of traffic when compared with this branch offices or the small locations, because any traffic which is connecting to this head office, probably it has to go via main head office, and maybe this can be your service provider network which is providing the connectivity, or it can be your main head office where you have all the centralized traffic goes. Now depending upon the amount of traffic flowing through the network and depending upon the number of interfaces we are connecting, it differs. Deciding the right router is very important here. So in this scenario, typically what we do is at these locations where we have some end locations, we can say, which is just connecting to main central head office or the central branch office, and you got a very less number of connections here, and also which means we need some less number of ports, and also there is a less amount of traffic. We can go with some access level routers. Now access level routers are the low end series routers which we use, and low in terms of processing, low in terms of number of ports, and also they are less expensive when you compare with some other level routers. And when you come back to these main branch offices, probably we prefer to use some distribution level routers which are a little bit high-end routers when you compare with access layers. And when it comes to the major centralized backbone network where you have all the centralized connections, majorly your head office, or it can be a service port network, we prefer to use very high-end series routers called core routers. Now this is the hierarchy which is designed by Cisco in order to meet the different network requirements in any network. So the next thing, how to identify the different platforms. So I got some screenshots of some of the routers here. If you just come back to my presentation here, I got some of the access level routers, some 800 series routers. They look like this. Mostly you can see there are some ports here, and ports, probably you'll find this is my 800 series router, Cisco 800 series routers. And I got a small router here. You can see this is my 1700 series routers. On the back side you'll find the ports. This is the front side. On the back side you'll find some ports. We'll get into that ports as well in our next classes. And I got some 1841 series routers. 1841. I'll come to these models as well. Now typically we call them as access level routers. Now access level routers are a little bit low end series routers, and by seeing these series numbers we can identify like 800, 1800, 1700, and then 25, 26. These are a little bit end of sale, not much you'll find, and we call this as access level routers. And typically some of the 2600 series comes under distribution level, 28, 38 series, and then 3700 series. These are typically referred as my distribution level routers, and the core routers starting from 6400, 7000 series, and then 8000, 9000 ASR series, and then 10,000, 12,000 series, 12,000 XR series routers. Now these are typically called as core routers, which are majorly used inside the service provider core networks. If you're working for a service provider, probably you'll find more of these devices on the service provider network, or even you can find on the big size companies where they have the centralized network built, which is going to deal with a huge amount of traffic. And I got some snapshots of these different models of the routers in my presentation here, and this will give some good idea on how they look exactly. They look a little bit like a flat box which have some ports on the back end. This is the back side of the router, and this is your front panel. It looks like this. 1800 series routers. If I just come down with some distribution level routers, this is my 2800 series routers, which are next level routers, and 3600 series routers, front and back, with some more number of ports. You can see here, more number of slots. And then some of the core routers, 7000 series routers. These are typically your 7000 series routers, which will be more bigger, and it has some more number of connections here. You can see more number of slots. And these are your XR series routers, XR 12000 series routers, which are typically found in your service provider network, where you got a lot. They support some very high speed processing, and also more number of ports here. Now probably at the CCNA level, we just need to have, when it comes to the command line, there is no much difference in the different level routers, probably distribution level or access level routers. But when you are using some high-end routers, probably these XR series routers or any other ASR series routers, they have some slight change in the command lines. Okay, so probably in CCNA level, we'll be getting into this. Mostly we'll be using some access level routers will be more sufficient for you to test out most of the CCNA concepts, like 1800 series or 1700 series will be typically sufficient for you to test out most of the CCNA labs.